Yeah, my name is Gary Kirk. I'm with Calportland Cement. So Calportland has 3 cement plants in California. So I'm just here to give you guys a perspective on a California cement producer from California. So as Tom mentioned, here's the PCA roadmap to carbon neutrality in October 2021. PCA and the American cement companies committed to being carbon neutral in 2050. They identified 5 Cs. That's clinker, cement, concrete, construction, carbonation, with concrete being the carbon sink. And they also went with the reducing emissions through the manufacturing process, reducing emissions through the alternative fuels, and using renewable energy. And then what was said earlier was California, they reduced that from 2050 to 2045. So this is the CNCA roadmap to carbon neutrality. They also have the 3 pathways: process emissions, reducing process emissions through the cement manufacturing process. That's very difficult because calcination is required for clinkering. So when you're decomposing calcium carbonate, which is limestone, to a calcium oxide and carbon dioxide, one way to capture all that is the sequestration, but that is capital intensive. That's kind of long term, but we are looking at that. Also, fuels, using alternative fuels. Natural gas is probably the easiest one, but then there's also biofuels, other fuels. We're also looking at that, but that is also longer term. And then electricity, using renewable energy and just being efficient. So up here, the first lever, the Portland limestone cement, that's the low-hanging fruit, as you could say. So that is having the clinker factor. So reducing the clinker factor, one way to reduce the clinker factor is just to replace that with limestone. And you can get about 10% reduction in your global warming potential for your EPD. So Energy Star, Calportland is committed to energy efficiency. We have been the winner of the Energy Star Partner of the Year for 19 years in a row. We're very proud of that. A lot of work. We also have, in our California cement plant, we have installed zero emission windmills. So we're able to produce 24 megawatts annually. And that helps us lower our EPD, our GWP. We also installed in California a fleet of compressed natural gas cement bulk hauling trucks. And we converted one of our cement plants in California over to producing Portland limestone cement. That's ASTMC 595 1L cement. So I think everyone's familiar with Portland limestone cement. It's the same clinker, same gypsum, same limestone. It's just different proportions. So it's kind of an engineered cement, trying to meet that same performance of a Type 2.5 cement with having 10% less clinker. So when we kicked off our producing the Portland limestone cement at Mojave, we also decided to roll out a brand new product line, and we branded it called Advancement. And tagline is environmentally friendly cement. So we have currently 4 products under this new product line. Advancement HS, that's made with the Type 2.5 clinker. It's a high sulfate resistant, completely replaceable performance-wise with Type 2.5 cement. We have our Advancement LT, that's made with Type 3 cement, but it's underground limestone. It's made with Type 3 clinker, and it's very light colored, really low iron, high alumina, very well received in the architectural work. And then we're working on Advancement HPT. This is a 595 1T cement, which will be ternary. We're going to blend our clinker with limestone and natural pozzolan to reduce that clinker factor even further to get a lower GWP. Then we also have the natural pozzolan as a standalone, which is a replacement for fly ash.
So the Type 2 would be an MS?
No, Type 2 would be MS, yeah. But we, in California, all the Southwest, it's all high sulfate, so everyone makes a Type 5 or Type 2.5. We actually, our mill certs, we branded as market as Type 125, just in case engineers, The C3A is under 5%, but it makes all the strengths of a type 1.
So the blended cement is going to be a 2.5.
The blended cement is just type 5. It's just high sulfate. It's a 1012. It's ASTM sulfate expansion test under 0.05% at 6 months. So it's they don't go with the Bogue calculations with the 595 cements because of the extra limestone.
Mm-hmm.
Can you talking into the mic there?
Yeah, sorry. All right, so here we go. We also, we have site-specific EPDs. So there's EPDs that use a national average, which is usually a higher number. We use the site-specific EPD at each plant. So that involves having a party come out and audit, measure all your emissions, all your electricity, and they're able to give you a GWP number here. So as you guys had mentioned earlier, I think it was in the mid-9s for the state average for GWP for type 2.5 cement. Our Mojave cement is lower at 824 already just due to us using renewable energy with our windmills. And then you can see with our Advancement HS, which is the 595 1L cement, that is considerably lower to the type 2.5 cement. So this here is just a focus on reducing the clinker factor. So this is just a table. As you can see here, type 125, 1P, 1L, 1T. So 5% max limestone, you're going to still need, about 95% clinker, the type 125 ASTM C150. And then when you get into the 595 cements, the 1L allows you a minimum of 5, maximum of 15% limestone. And the 1Ps, you can reduce your clinker factor all the way down to 60. And then when you get into the 1T cements, this is where you can really move the needle and do some considerable replacement and get that GWP number significantly lower. Here's the acceptance map of Portland limestone cement. This is a national, so 45 of the 50 state DOTs throughout the nation currently accept Portland limestone cement. And the remaining 5, they've all been switched over to this planning to accept light green color. So, this map looked quite different just a year ago, especially 2 years ago. And the reason that this is all possible is all these building codes and specifications have now allow Portland limestone cement. So it's just a lot of synergy going on to promote Portland limestone cement.
What are the states that don't accept?
It's in the Northeast. I think there's Hawaii, and then most of these are all in the Northeast, Maine, Vermont, all up in this corner. I think the last one was, I believe it was Arkansas was the last one that changed. That was more southern.
And all those in the Northeast are very soon, they're just working through.
They're working through there? Yeah. Yeah, I know I'm on the communications team for the task for the limestone harmonization, so. And this is just kind of bringing it back to Southwest local. So in all of 2022, we had Caltrans, Arizona DOT, Nevada DOT. They all switched over to accepting Portland limestone cement. And last slide is kind of just when we promote ASTM C595 cements, we kind of say today's market is a 150 and a 1P. Tomorrow's market's going to be a 1L, and the future is definitely going to be a 1T, just trying to lower that clinker factor to get that lower GWP for the EPD. So,
all right, questions for Gary from the cement perspective?
Sure.
Just, I've enjoyed looking at what you're doing as far as what you're trying to do, lower clinker. I was just curious, are you also increasing volume capacity at the same time?
You would think you would. If you're replacing clinker with limestone, you would just automatically have a 10% more output at the plant. What we find is you have more time in the mill. So the same clinker going into the mill with the extra limestone, so you're having to grind it finer to keep that same early strengths, and it's a wash, or if not less production, making 1L compared to 2.5.
I mean, that makes sense to me, but do you have plans to increase capacity? Because if we're importing as much as we are right now, it would seem like there's a financial opportunity there.
Well, it's capital, very, very expensive to expand, and then you also have permitting to expand. We did do a big expansion at our Oro Grande plant. We put in a new finish mill, which that was kind of our bottleneck, but I think that was a $70 million expansion. So I think the importing, you asked a question about the 1L cements. We are importing 1L cements into the Northwest. We're looking to import 1L into Stockton terminals, but we have a dome, and so we don't want to get into layering different cement types.
Right.
So we have to, and unfortunately, we can't get a commitment from one import supplier to supply 1 million tons per year. So we use currently 2 or 3 different sources, but they're all ASTM C150 cements. Yeah.
So, as you talk moving on to the 1T, how does that differ from if I'm at a concrete plant and I'm blending other pozzolans in there, other than maybe you're optimizing around your cement, but then, how does that impact capacity and everything else if you start doing that all in the cement plant? Or, so I'm just...
Yeah, so
Can you repeat the question, Gary?
So he was asking if we start intergrinding all these SCMs, so we have a cement that has built-in pozzolans with the cement, how does that impact ready-mix companies? One way it could be a bonus where you could have you have a committed fly ash silo, and now you have a cement silo. You could start putting cement in both those if whatever the blend percentage was meeting your ASR and sulfate needs, or if you needed further trimming with the fly ash, you could still just replace the cement with the fly ash like you currently do.
And then what does that do to your overall capacity again?
Yeah, we're currently looking into 1T. We made a few trial grinds. I'm not sure the throughput on that. So there's a lot of exciting stuff going on. They're even looking at, possibly grinding individual ingredients and blending them later to see if that helps on performance, but that's expensive and you got to convey and blend. And so it will probably be similar. You're going to be using less clinker, but you're going to be doing more SCMs and more grinding time. But it could be, it could increase tonnage. Have to find out.
Next question.
How do you account for your upstream and downstream energy fluctuations? So if I'm looking at the life cycle assessment of, say, a windmill, and now you have to dispose of that windmill, how does that impact your GWP? So, for example, I've heard that the blades from a windmill can't really be reused, so they have to be disposed of. So how does that factor into your GWP, or is it factored into your GWP?
I don't know the answer to that. I know the EPD, when it was, we had a company come out and audit the plant and go through all the electricity, energy uses, and all the emissions to make the cement. I know there is, like in the Mojave, we have what they call wind season, which is starting about now, where you get higher wind during certain parts of the year and it's slower. So all I know is that the windmills are about 24 megawatts annual output.
But not very efficient.
They're, zero emission. I don't know about efficient.
You should look at the energy efficiency. It's not that efficient.
Okay. I don't know.
I've got a question here, and,
Yeah.
and it's the elephant in the room, I think, is what it is. We all know that by reducing the total cement content, replacing with supplementaries and ternaries and whatever else, that it's going to help definitely reduce the greenhouse gas emissions and whatever else. Trouble is my experience anyways, you're dealing with, especially in big civil projects, you're dealing with regulatory authorities like AREMA, like Caltrans, like MTO in Toronto or Ontario and all that kind of stuff that say, show me the historical performance of a reduced or a changed proportions that can be a durable product and resist chemical attack. and I want to see it in our structures. How do you deal with that part? Because typically what it is, it's a chicken or egg, and you have to have 10 years of historical performance to be able to initiate the fact that you can do this kind of a radical change. And we're talking about a big radical change between now and 2050. And that's the problem I see, and I've had in all the things I'm dealing with. I can show how it performs short term, but I can't say, yeah, this has been 30 years of historical perspective, and it does resist, and it doesn't turn into a horrible mess. And that's the thing. How are the regulatory authorities dealing with this, and especially in their specs?
Yeah, it's a lot of boots on the ground, getting in front, trying to educate, and we have this a lot with even with engineers for companies like trying to get. There's not a whole lot of historical for wastewater treatment plants. So 1L cement, even though it's been for pavement, a lot of other things in regards to wastewater. We haven't been able to in California get a 1L job going yet, and try to. We lean on the Jason Weiss report quite often, and that was Caltrans spent a lot of time and money with Jason Weiss, and I think it was a 3-year study. It's a
That's the Caltrans study.